An elementary product is a product of n entries from matrix A, no two of which come from the same row or the same column. For an n by n matrix, this is n entries. For a 2 by 2 matrix, 2 entries. A 3 by 3, 3 entries. A 4 by 4, 4, and so on. Using the 2 by 2 matrix as the example first, the elementary product for a 2 by 2 matrix is going to be the product of 2 entries, no two of which come from the same row or the same column. If I just pick one, A11, I've got to multiply 2 entries. The first one, A11, A11. The next entry by which I need to multiply it by cannot come from the same row or the same column, which just leaves A22. So an elementary product for this 2 by 2 matrix is A11 times A22, and there can be more than one. There's another one for a 2 by 2. I can start with A12. Next one cannot come from the same row or the same column. A12 times A21. This is another elementary product. And it doesn't matter if I start with this row or this row. If I start with this row, say A21, column and row, A12, A12, A21. Same thing. Moving on to a 3 by 3 matrix, the elementary product, or unelementary product I should say, for a 3 by 3 matrix will consist of 3 entries, no two of which come from the same row or the same column. Starting with A11, I pick this as the first entry. The next one cannot come from the same row or the same column. Now I've got a choice to make. Pick A22, A23, A32, A33, and regardless of which row I pick it from, it will end up the same. So I just like to go along, I like to pick one from row 1, then row 2, and then row 3. A11, now I'll pick A22. Same row, same column, left with A33. A11, A22, A33. This is an elementary product. Of course, at this point, I could have picked A23. Same row, same column, A11, A23, A32. And of course, again, if I decide to pick from the third row first, A11, A32, A23. So same thing. Then just continue along, start with A12. Same row, same column, and again, pick this one, same row, same column. And here it is, A12, A21, A33. That's another elementary product. And for a 3 by 3 there are going to be 6 total, but we're just thinking of them on their own as of right now. And of course an elementary product can have a positive or negative value. The positive or negative value is going to depend on the permutation. The permutation, whether it's even or odd. The even or odd properties will depend on how many inversions it has. So think of this as x, y, and z. X, number y, number z. These are set values. Think of them as 1, 2, and 3. Now look at these and these elementary products and then determining how many inversions there are. If there are an even amount of inversions, then it is an even permutation. If there are an odd number, then it's an odd permutation. If it is an even permutation, it is positive. If it is an odd permutation, it's negative.